Hi there, this is A-level further maths combinations for discrete maths. It's very similar to some of the stuff you get on statistics unit for OCR further maths. So if you are doing that, you possibly have seen this before or seen something similar in class or whatever. So just bear that in mind. Likewise, if you're doing some other version of further maths, the discrete or decision unit, you might find this is not on your syllabus. On the board I do for Edexcel now, it's not included. So just bear that in mind as you go through this. Make sure you need it. Okay, let's do a little starter first of all. How many different 7-digit numbers? Oh, importantly, it says different because I noticed some of these numbers are the same. So I'm going to have to bear that in mind. How many different 7-digit numbers can be formed in digits that, assuming that none of the numbers can start with a 0? Okay then, I suppose one way of doing this is for, first of all, it can't start with a 0. So straight away, I've only got 6 numbers out of my 7 that can go in my first place, if you like. 1, 2, 3, 4, 5, there we go. And how many can go in my other ones? Well, I suppose now I've got 6 in that first one. There are, let's say it was a 3 I chose, there are still another 6 numbers to go. And now the 0 can be included. So there's 6 times 5. And notice I'm times in these. 4 times 3 times 2 times 1. Now the temptation would be to think that would be the answer. I don't think it actually is, because some of the numbers are repeated. So let's just work that out first of all. And then I'm going to have to divide by the repeats. So 6 times 6 factorial, I suppose, ultimately, that's 4320. As I say, I think I then have to divide that by the fact that some numbers are repeated. What am I dividing by? I've got a 2 factorial, and I've also got a 3 factorial. So let's divide that by, what's that? Divide by 2 and divide by another 6. I get 360. So I'll check that in a bit. And then part B, what does part B say? How many of these will end in the letter 0? All right, so number 0. So it's very similar. We've still got these 7 places I can put my numbers. Hopefully I've got the right number. 1, 2, 3, 4, 5, 6, 7. Yes, I have. Still can't start with a 0. So there's 6 ways I can fill that. But the last one has to be a 0. So there's only one way of doing that. But all the others, presumably, there's 5 ways of doing that. There's 4 ways of doing that. 3 times 2. So it definitely is a restriction on last time. So that is just 6 factorial. So 6 factorial is 720. And again, I've got the repeats to deal with. So I'm just going to do the repeats. 720 shared by, I've still got 2 2s and I've still got 3 3s. So divide by the 2, divide by the 6, and I get 60. Let's see if that is right. It's 360 and 60. So that's good. So I like that. So look, we are looking today predominantly at combinations. We haven't seen that there. That was more like arrangements, but a good practice of what came before. Now let's just go back onto my starting slide. This is what combinations mean. Some people, by the way, use the word choose because it's on the calculator. This is on the NCR button. And the NCR combinations, or choose, they say. Because I suppose it makes sense, because I've got 5 dinner guests here, and I want to choose 3 of them who can sit down at my table, because I've only got 3 chairs. And we saw something similar on the last exercise, 1B.2. That was called permutations. Now, on permutations, I cared where they sat. On combinations, I don't really care. So if I've got the artist, the magician, and Superman sat in that order, that's the same as far as I'm concerned now as them sitting in the order of Superman, the artist, and the magician. In both ways, the what looks like the librarian or whatever it is, and that's probably a teacher and a nurse. But these people are not sitting down at all. The other 3 are sitting, but I don't care which way round. So just bear that in mind. Anyway, that was the starter, and let's look at this. So I have highlighted a couple of things for you here. Now this is the this is the new calculator, and on the new calculator you should be aware, by the way, that what you've got to do, I've made you make sure I know what it is. I haven't got the calculator with me this one, annoyingly, but you have to press say I want to do. Let's give myself an example. That's the posh formula, by the way. I try not to use it wherever possible. Sometimes you get forced to because they kind of do it in algebra, but most often they don't. So let's say I'm doing this. So I've got 10 things. So I want to do 10C3. And if I do 10C3 on this calculator, I have to press the 10. So I'm going to type in the 10. And then I have to press the catalog button. You can see the catalog button. And then it will come up on the screen and I'll press probability. And then you very quickly see combinations as one of the options. And having done that, it'll pop the C onto the screen. You can type 3 and you can type the equals. So that's how you do it on the new A-level calculator. I suppose if I use the formula, I should really try to show you the formula. So as the formula says, you do 10 factorial because that's my first number. I'm choosing 3 of them, so I do 10 minus the 3, that's 7 factorial. And I divide by the 3 factorial. So I'm just going to type it into my calculator. So 10 factorial, and I'm just literally going to type this in, divided by the 7 factorial, and I'm not really too fussed about showing much working out here. I get 120. Did I do this already? Yeah, I've got 120 there. And by the way, I've noticed I've shown up the old Casio class whiz here because the old one used to do it there. There's an NCR button just above the divide, and you just have to press the shift or second function, whatever it says, and the divide button, it comes up immediately. So it's a bit quicker. This, if I had to choose a calculator, personally, I would choose this one, simply because it's got more buttons, and therefore you have to end up pressing the menu less. So you can do this straight from the calculator, and in some respects that's better than using the formula. But as I repeat, sometimes you've got no choice but to use the formula. Look, I've got a few questions for you on this. First one's got an old manager now, but at the time it would seem he had 16 players, and he wants to choose 11 players to start a match. Now, sometimes, again, just be aware, sometimes they describe this as selections. If you think of football teams, selections makes more sense. So we'll look out for the word select or selections or choose, or it might even say combinations. How many different teams could he choose? Well, presumably he's got 16 players. He's choosing 11 of them. It's 16C11. So type that into my calculator. 16C11. 4368. Okay. What's he? Look, in reality, of course, that wouldn't be a great team. Some of those he chooses. I think it should be an S there. A formation of 1-4-4-2. Now that basically implies that he had some goalies. In fact, he had 2 goalkeepers, of which he chose 1. So the way you do this, you kind of say, well, he's got to choose from his goalies to see 1 of them. And so times it. From his defenders, he's got 6 defenders, he's got to choose 4 of them. And now I suppose I'm relying on a bit of knowledge of football here. I'm sure a real exam question will make it more obvious what 1-4-4-2 means. But basically, from his 5 midfielders, he's got to choose 4 of them. And lastly, from his strikers, of which there are 3, he's got to choose 2 of them. So I'm going to again type that into my calculator. So 2C1 times 6C4 times 5C4 times 3C2. Hopefully I've typed it in right. It says 450. Let's see what my answers were last time. 4368 and 450. So it works. So this is very common that you kind of get a question which says, look, you've got all these options. And by the way, now we're not going to give you so many options, and you've got to break it down a bit. Let's see here. How many different ways can we select a committee of 5 people from 3 men and 7 women? All right. So, well, I suppose first of all, it says no restrictions on its members. So there's a total of 10 people that I can choose from. So this first one strikes me as being I've got 10 people to choose from, and I've got to choose 5 because it wants 5 people on my committee. I think I made sure when I wrote this question many moons ago, there were 10 people around that table with 3 men and 7 women. Anyway, let's do this now. I'm going to do 10C5. I've got no restrictions at all. 252. So I've got 252 ways of picking my committee. but sometimes you might have specific quotas to fill. So now I've said I've got 2 men. So of those 2 men, there was only 3 to start with, wasn't there? So 3C2. Of my 3 men, I've got to choose 2 of them. That means of my 7 women, I've got to choose 3 of them. So let's see what that gives me. 3C2 times 7C3. I get 105. There we go, 105. They must contain at least 1 man. I suppose I could think about this. If it's got 1 man, that's at least, it could have 2 men or it could have 3 men. So let's just do that. It's probably easiest. So I could do here, of my 3 men, I could have 3C1 times by, well, if I have 1 man, there must be 4 women, so 7C4. Or, so I put a plus. So now I'm going to have 2 men. That means I've got to choose 3 women. Or I could have 3 men. But that means I can only now choose 2 women. And you can just break it down in those kind of ways. So 3C1 times 7C4, I get 105 again. So what's the next one? 3, that's 105 already. I don't know why I put, should be the plus. That one, 3C2 times 7,3, I've already worked out. And this one, I've got 3C3 times 7C2. And I get 21 for that. So that sounds like 210, 231 different ways for that to happen. Let's check the answers. 252, yes. 105, yes. 231, yes. Okay, that's good. Okay, cards. Now, you do get questions on cards. When I was at school, there wasn't many video games about. So people did play cards a lot, and lots of old people still play a lot of cards. But nowadays, I understand that you guys possibly don't. But I suppose you still need to know some certain basics. So let's just go through some basics. There are 4 suits. The 4 suits are called hearts, diamonds, spades, and clubs. And it's important to know that these are red suits, hearts and diamonds, but these are black suits. So that's why you've got reds and blacks within this pack. Now, you should know that for each one, there's 13 of each, which gives you a total of 52 cards in the pack. And that's where there's 52 cards. So imagine I've got these 52 cards and I want 5 of them. And how many ways could they be dealt? But there's no restrictions at all. It's just 52C5. No idea what that is, but I shall type it in. 52C5. That is 259. That's a big old number, actually. 2598960. There we are. And how many ways could the 5 cards contain 3 hearts? Now, if I got 3 hearts, so of my 13 hearts, remember I said there are 13 up here to start with, 13 of them, I've got to choose 3 of them. Don't care which ones, but I've got to choose them. And of the other 39 cards, I've got to choose, well, I want 5 in total, I've got to choose 2 of them. So it's 13C3 times 39C2, and I get still a big old number, 211926. Okay, let's see if we're right. They look right. We're going to do now a little exam question with you. So here goes. Now, please bear in mind, this is actually a proper decision question. It's not from A-Level Statistics module. This is taken from the 2022 paper on from the Discrete. So this is important that you realize these questions do come up. Now it says here, how many different ways are there of choosing 4 swimmers from 7? And that's basically a nice combinations question. So it's well, I mean, we've got, as I say, 4 swimmers from 7. That just sounds like 7C4. Let's see if my pen's going to work. Yeah, 7C4. So I get my calculator. 7C4. I've got 35. Now, there are no restrictions, it says, on how many men and how many women are in the team. The group of 7 swimmers consists of 5 men and 2 women. How many ways are there to choose a team with more men than women? All right, then more men. So I suppose, how many men did we have originally? 5 men. So we're going to have to add, of my 5 men, I suppose I could have 5C. Well, how many? I want 4. So I could use 4 of those and end up of the women, choose none. That's one option. Or I could do just 5C3 times by 2C1. I could have 1 woman. I think that's probably it, isn't it? Because if I had an extra woman, that'd be 2, but then there'd be 2. I think that's it. So 5C4 times that 5C4 is simply 5 plus 5C3 times 2C1 should be 10. Oh, if I typed it in right, 5C3 times 2C1, that says 20. So there you go. So that gives me a total of 25. Okay. The physical impairment of each swimmer is given a score. All right. Remember, this was, I didn't even read the question, but I do remember. It was a Paralympic relay team or some description. And these are the scores of the 7 competitors. The total score for the team must be 20 or less. How many different valid teams are possible? Well, I suppose this comes down to, can we list the combinations, arrangements, selections, whatever you want to call it. But basically, for this team, for instance, 3, 4, I need to be under 20. 3, 4, and 4 is 8 is 11. All right, then. So I could have theoretically any of these other people. So I could have a 6 that's under 20. 3, 4, 4, 7. So I made that 11. That's 17. You see, this is now 18. I think I can do 8 and 9. 3, 4, 4, 8, and 3, 4, 4, 9. And that is, and I was just quickly checking, it's 20 or less. So that's got 4 ways of doing it. What else could I do? Well, if I don't have the 3, I start getting bigger numbers quite quickly. What do I get? I get a 4, a 4, a 6, and a 7. Now, 8. Now that is too big. That's too big. I think I've got to have my 3. So the only thing I can out is one of my 4s, I think. 3, 4. So we then need the 6 and the 7. What's that? Make 7, 14. That does make 20. That's okay. Now, just bear in mind, there are actually 2 4s. So we could have that 4, or we could have that 4. So I'm going to write exactly the same thing twice. But that's because, oh, what's going on there? 3, 4, 6, 7. And that makes, I think, again, 20. And that is definitely different from this one, partly because I've made such a mess of writing it. But there are 2 4s, so I need to write it twice. So that makes a total of 6 ways, I think. Okay, let's just check my answers. I got these from the exam board, so these should be right. 35, we got 25 and 6. Good. There was actually a part D, but that was, I think, from memory equipped. So we don't want to worry about that on this video, but do by all means look at Quicksort as so. So look, this comes down to the exercise 1B. We've been working our way through it. I've already posted online the 1B.5. I've got to do the 1B.4, but eventually all of these will be up and running, and you can then attack exercise 1B from the textbook or whatever other textbook you're using. So this was just the one I used in my last course. So best of luck in your exams, and that's it for now. Thank you.